Okay, so this is still talking about quadratic equations, but given certain scenarios, especially real world situations. When we're talking about projectile motion, you have to imagine this is more of the, I guess, the physics involved. So like, for instance, we're talking about the path that a soccer ball follows is pretty similar to a parabola, okay, because it looks like almost a hill. If you think about, you kick a ball, it goes all the way across and hits the ground on the other end. Other cases you might see it is a diving board. Whenever you first jump off of a diving board, you have an initial lift and then goes down to the water. Some other ones we might think of, roller coasters, trampoline, those kinds of things. So we are going to focus on features of a quadratic equation given a real world situation. So for instance, number one, a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation, h equals negative 16t squared plus 90t, gives the height of the ball after t seconds. So this is a quadratic equation. We're just used to seeing it, instead of h, we see y equals, and instead of t, we see x squared plus 90x. So you can think of them as the same thing, but the reason why they use t is because t represents time in seconds, and hy represents the height after so many seconds. So they want us to find the maximum height of the ball, given this equation, and then how many seconds it will take for the ball to reach the ground. So what we're going to have to do is type this into my y equals screen, type in negative 16x squared plus 90x, and what we're going to do is hit graph. And at first, you're going to see part of it, but then you only see it looks like a line and then it comes back down. So we need to get a better picture of what this looks like. When we're talking about real world situations, we have to think about context. In this particular case, there is no such thing as negative time because your x-axis represents time, which we don't need to see the negative side of it. So our focus, and we really don't even need to see below the ground in this case because the ball does not dig itself underground. So we're just gonna need to look at the first quadrant. So we're gonna change our window here. This is something new that we haven't really touched a whole lot. The window, which is next to y equals, we want our x min to be maybe -1 because we don't want to go anything beyond -1, but we want to see the origin. And our x max, well, our x max is going to vary depending, but I'm just going to put, I guess we can put 20 to start. And then we go down to our y min. Again, we don't want to go below the x-axis because it doesn't go underground, so we're going to go -1. And then we'll keep this one 20, but we might have to adjust it. So now that if I look at my graph, all I see is the first quadrant. Now I didn't zoom out far enough because I can't see the maximum that this ball hits. So we're going to change our window and change the y value, the y max. Let's try 90. Again, this is kind of just a guesstimate. Okay, that still wasn't enough. So let's try maybe 200 just to get a better look at it. Okay. So there it is. This is a better picture of what's happening in the situation. So imagine this is a soccer ball, which starts at the origin, okay? And it gets kicked off the ground with an initial velocity of 90 feet per second. So then if you follow the path of the soccer ball, it hits a maximum height, and then it starts to go down and then finally land on the ground. So they want us to find the maximum height of the ball. That's this vertex right here, the max. So in order to find that, we are going to hit second trace, and we want to find the maximum. So that's number 4. Now, and then I believe all you do is you want to make sure you're on the left. Ooh, did I go too far? Yep. So I want to make sure my cursor is on the left of the maximum and then on the right of the maximum, and then hit enter a third time to where it's going to find my maximum height. Now, x represents time here. So we don't need the x value because it's not asking how long does it take to reach the maximum, it's asking what is the maximum height. So we're actually going to look at our y value, and this represents height in feet. So we can leave it as a decimal. I'm going to round to the 10th place. So the maximum height that the ball hits under this velocity is 126.6 feet high off the ground. Okay. Then the next question says, how many seconds will it take for the ball to reach the ground? So if I look at this as a situation here, the ball gets kicked, it goes to a maximum of 126 and then starts falling down. This is where it hits the ground, because think of the x-axis as the ground. Okay, so they want us to find this, they want us to find the x-intercept right there. So in order to do that, we can set it equal to 0, where y2 is 0, and hit graph. And we want to find the intersection of that point right there. So second trace 5. It's not the only way to do this in the calculator, but it's just one of them. But I want to make sure my cursor is close to that intersection. So then I'm going to hit enter, enter, enter. Okay, now let's talk about this again. The y is the height, but we don't want the height here because we know the height is 0 once it hits the ground. We want how long it's going to take for the ball to hit the ground after it is kicked. So how long does it take? Well, x represents time in seconds, so it takes 5.6 seconds to hit the ground. Let's take that same idea, and this time a different scenario. An apple is launched directly upward at 64 feet per second from a platform 80 feet high. The equation of this apple's height, h, and time, t, in seconds after launch is h, which is y, equals negative 16x squared plus 64tx plus 80. So again, we're going to type this into my y equals screen. Okay. Now this time, if you notice that it did not start at the origin, but again, we don't care about the left side of the y-axis because we're talking about time, and time doesn't go to the negative amount. But think about why it crosses the y-axis at this point right here. The reason why it crosses the y-axis at that point is because it says that an apple was launched directly upward at 64 feet per second from a platform that was already 80 feet high. So this y-intercept of 80 is where it was launched. It wasn't launched from the ground. It was launched 80 feet from the ground. So then it got up to a maximum height and then finally landed on the ground over here. So they want us to find the maximum height of the apple. Again, we're going to do second trace maximum, which is 4. Make sure that we're on the left side of that maximum. And then we're going to make sure we're on the right side of that maximum and then hit enter. Again, a third time. So remember, x represents time here. So at 2 seconds, which they don't ask for, but at 2 seconds, it hits a maximum height of the y value, which is 144 feet above the ground. How many seconds will it take the apple to reach the ground? So since we already set it equal to 0, all we have to do is find this intersection at the x-axis. So second trace 5. We're going to make sure our cursor is close to that x-intercept. Enter, enter, enter. So at a height of 0, because it hit the ground, it finally hit the ground after 5 seconds. Okay, another scenario. In science class, the students were asked to create a container to hold an egg. They would then drop this container from a window 25 feet above the ground. The height h, or y, equals negative 16x squared plus 25, gives the container's height after h after t seconds, time in seconds. So again, we have a new scenario here. This time it is an egg that is being dropped from a window that is 25 feet above the ground. So you can imagine, let me change my window here because it's not hard to tell, but we want to make sure we can get a better picture of it. So I don't need my y maximum to be very high, so I'm going to put 100. A little bit better, so we could maybe change it again to where we get a better picture of it. So it's maybe 50. Okay, so this is kind of a better picture. So the idea here is that if you look at the situation we're in, we don't care about the left side of the y-axis because it's not negative time. This time an egg was dropped from 25 feet above the ground. Okay, not thrown, but dropped. So if you notice the difference here, the maximum is where it was dropped. Whereas the other ones, because they were thrown up, they had hit a maximum and then they were dropped down. In this case, it was just dropped, which is why the maximum we can already guess is 25, because that's where it was dropped above the ground and then finally hits the ground after so many seconds. So let's double check to make sure we're correct. If we find the maximum here, which is 4, we want to be on the left of that maximum. I'm just hitting my left arrow, enter, and then on the right side, enter. And my maximum is 25. So, because it was dropped from 25 feet at a window, okay? It wasn't thrown and tossed to hit a maximum, so that is the difference. How long does it take to reach the ground? So this is like what we did before, where we're going to find the intersection of that x-intercept. Enter, enter, enter. And by the time it hits the ground, it only takes 1.25 seconds. New scenario, a penny is dropped. Remember, not thrown, so we can imagine it's going to look similar to this. A penny is dropped off the Empire State Building, which is 1,250 feet tall. If the penny's pathway can be modeled by the equation h, which is y, equals negative 16x squared plus 1250, how long will it take the penny to strike a 6-foot tall person? Okay, so this one has a lot involved in it. Again, we want to change our equation to negative 16x squared plus 1250. We're going to have to change our window here because, because 1250 is such a large number, so we're going to have to change that y maximum maybe to, so you change your y max depending on the y-intercept, so we're going to do 1300. There we go. So there's a good picture. Okay, so imagine this is the Empire State Building and a penny is dropped. So it's not thrown where it has a hill. It's just dropped. And then by the time it hits the ground over here. Now, what's different here is they're not asking for the max because we already know the max is going to be 1250. They're not asking how long it takes to hit the ground. They're asking us this time how long it takes before it hits a 6-foot tall person. So instead of having 0 in my second y equals, we are going to have 6 here because we don't want it to hit the ground. We want to hit 6 feet above ground. We want it to hit a person, sadly. So it's going to look a little different where the red line, it looks like it's on the x-axis, but it's not because our y-axis is so large that it looks like it's on 0. So this represents the penny hitting the person at 6 feet. So we're going to find that intersection by moving my cursor close to it and hitting enter, enter, enter. So in order to hit a height of 6 feet, it takes about 8.8 seconds. So a little bit different there. Some fireworks are fired vertically into the air from the ground at an initial speed of 80 feet per second. The equation from this object height and time, t, seconds after launch is h, which is y, equals negative 16x squared plus 80x. How long will it take the fireworks to reach the ground? So this time, it gets thrown from the ground and goes up. So you imagine it is going to look like like what we've been seeing. Okay, so because our y-intercept is 0, we're going to have a smaller window. So we need to change that 1300, and I'm just guessing here. I'll change it to 500. Okay, a little bit better. I'm going to change it again to maybe 200. Not that I can't figure it out from there, but I'm just going to get a better picture. There we go. Okay, so some fireworks were vertically fired from the ground and shot up to a maximum height and then finally hit the ground. But this time they want to know how long will it take the fireworks to reach the ground. So they don't want to know how high the fireworks get. They want to know how long it takes before it reaches the ground, which we changed our y2 to 0 again because that represents ground level. So then we're going to hit second chase 5, and I want to be close to the intersection over here on the right side. And then hit enter, enter, enter. So it takes 5 seconds to hit the ground after the fireworks are thrown. The Apollo's Chariot, a roller coaster at Busch Gardens, moves at 110 feet per second. The equation of the ride can be represented by the equation h, which is y, equals negative 16x squared plus 101x plus 10. What is the maximum height reached by this ride? So again, we're going to type that in. Okay, this time they don't want to know how long it's going to take for it to reach the ground. It wants to know how long it's going to take, or what is the maximum height. So my window is way off here, and I want to get a better picture of that maximum. So I'm going to change my Y max to maybe 20. There we go. So now this is a better idea. This is a roller coaster at Busch's Garden that moves at 110 feet per second, represented by this equation. They want to know what is this maximum height that the roller coaster hits. So we're going to do second trace 4 for maximum, and we're going to be on the left side of the maximum. Enter, then the right side of the maximum, enter, and then enter a third to find that maximum point. So at 0.3 seconds, which that's not what they're asking for, it hits a maximum height of 11.6 feet. Last but not least, Ava is jumping on a trampoline. Her height h at time t can be modeled by the equation h, which is y, equals negative 16x squared plus 20x plus 6. Would Ava reach a height of 14? So this one's asking a different kind of question. But if we type it into y equals negative 16x squared plus 20x plus 6, they want to know, will Ava reach a height of 14? Well, we have to figure out what is the height that she reaches. So what is this maximum? So we're going to do second trace 4, be on the left side of that maximum. Then on the right side, and then enter a third. So it reaches a height of 12.25. And they wanted to know if she reaches a height of 14, which she does not. So this would be no, because she only reaches a max of 12.25 feet.